Okay, last time we already talking about the operational amplifier. What I want to make sure you're able to recognize the inverting amplifier and the non-inverting amplifier up to this point. Okay, so this is basically I just try to review. Okay, when you're looking into the circuit, okay, and make sure you recognize it is the non-inverting amplifier. The thing is the input applied to the negative. Okay. And also, we already summarized, okay, the gain of this amplifier will be minus RF over R1. Okay. And the input and the output will be inverted. Input positive, output negative. Input negative, output positive. If you get a signal sideways, input positive, output negative, okay, they just opposite or 180 degree of phase. Okay, okay, and the second one, non-inverting. Okay, non-inverting, that means the input apply positive. Okay, and the gain, and here they already telling you the gain. Okay, let's see. Gain equal 1 plus RF over R1. However, make sure input have to connect directly to the positive of the op-amp. This is the input, but it's not really input will be using in the formula. Okay. Last time we already come up with to this point. So you get any question or any confusing, let me know before we keep moving. Okay. If it's not, now, can you do for me the example for the circuit show? They want the gain, okay? And they want the V out, and they want the current to 10K. Go ahead and see how many people can get through it. Make sure you have to do it, okay? Try to do it. What is the gain? Okay, number one, who get the gate? What the gain you get?
Just to check, so the equation for the non-inverting op amp was 1 plus RF over R2. Is that the one that we're doing?
Yeah, get the
Okay.
gain.
So would the answer be 23?
Perfect. 23. Now what the V out? They given you V in, 2 volt peak to peak.
Is it 23 times 2?
All right. The last one, the current. That means the current flow here. First thing, make sure you know what the voltage here, what the voltage at this point. And you know that V in 2.2 volt peak. Okay, so you understand a the voltage VD. Okay, V at positive minus V at negative. And you we already talking about VD all the time, 0. So that will be telling you V at positive equal V at negative. And the V in equal 2 volt. Okay, that will be telling you V at positive and a V at negative the same. So you get 2 volt here. So Ohm's law that given you current I equal 2 volt divide 10K. You get 0.2 milliampere. That's a very, very, very basic problem. Okay? You have to get that done. Okay? That means you tell me you understand it. You want to be a technician. Okay? The basic must be understanding. Okay, any question regarding to the first example? Okay, if it's not, go ahead to the next example. Okay, they given you the op-amp circuitry. If we're looking into that, we know that will be a non, that will be an inverting amplifier. Okay, and they given you the gain, and they asking about the value of RF. So you understand the gain, ACL, minus RF over our, our RI. Okay, and that will be equal minus 100. And now you already know RI. You want RF, that's a simple. Okay, 2.2 times 100. Is it 220? 20, correct? Okay, any question, anything? Okay, now go to the next one. Unity gain. amplifier. You can see very simple. No resistance in here. Okay. Only they connect output back into the negative. So you know the gain, they will be a 1. The thing input, output will be the same. Okay. So whatever input, and they will be the same, appear on the output. Okay.
Hello?
Yeah.
Yeah, I was looking for my AirPods. It's because I found out that my other phone is here, so I'm using that as Zoom. But I'll probably just let you go because I can't find my AirPods. I don't know where I put it.
So
No, my bad, babe. Yeah, my bad. I'll just let you go. Uh, okay, babe. I just got off from the freeway. I'm in downtown. I'm going by the streets right now because it's pretty bad. Traffic's bad. All right, man. Well, I love it too. Bye.
okay.
Oh, that you already got home, huh?
Yeah.
Oh, okay, okay. Was traffic bad?
Now the thing is, don't worry about that. You just do the job. Okay.
Damn, 4.0 for gas?
No.
Well, how much was it back then?
That you could just working on to upload it. Okay.
Oh, so it went
I
uh
checked that
five
and I
it
give
went
you credit or not.
0.5 down then. 0.5. I
Okay.
wonder how much is the hotel.
Command you mute yourself, please.
Okay. So what
Damn.
you
We'll see, we'll see. That's crazy.
Ricardo, we can hear your phone conversation.
With the low price? Yeah. Less than 100.
okay. When you're looking into the circuit, you know that is what they call unity gain amplifier. Only thing is input, output, identical. Same thing. Okay? So that is telling you the gain equal 1. Okay? And all the time, V in and V out will be the same. Okay? The next one, summing amplifier. Okay? This is like inverting. You see that? You get a negative right here. However, input not only 1, they get more input, V1, V2, and V3, and maybe more, doesn't matter. So the output will be, okay, first thing you see the negative here inverted. Okay, V1 adding to V2 and adding to V3. If you get more, you can keep adding. So nothing to talking about that. That is basically the formula to calculate for the summing amplifier. You're looking into the circuitry. You know that is a summing amplifier. And how can we calculate the V out? Okay. Now, the maximum rate of change of output voltage in a response to a step input voltage, a slew rate of the op amp. The slew rate is dependent upon the high frequency response of the amplifier stay within the op amp. Okay, so basically, if you're looking into that op amp, what is it? What type? What type of this op amp? You see, the output connect back directly to the input. So that is a unity gain. Input output will be the same. That's what we just go through that here. Okay? Now, see what happened. Okay. If you're looking at the input, this is the input here. Okay? However, the V out is not exactly the same. That's the V out here. You see that? They delay. Okay? They will be okay here, but at the beginning, they delay for delta t, take a little time, okay, before they try to get exactly the input applied. That's what they're talking about, the slew rate. They will be calculated by take the delta V out divide delta t. This is the delta t. Okay? Now, where delta V out equal positive maximum minus to minus negative maximum. Okay? That's the V maximum. That's the minus V maximum. Unit of slew rate is volt per microsecond. Okay? So basically, normally, when you apply the input, the output will be going identical. Okay? For unity gain amplifier. However, basically they're not completely exactly. Okay? That means the output they will take a slower. Okay? To get to the output like we can see. This is the input here. Output supposed to be identical, but they're not. They take a delta t time. Okay, before they will be saved. That's what they're talking about, the slew rate. Okay, if you want to calculate the slew rate, you take a V positive V max minus to minus V negative max. Okay, and the unit will be volt per microsecond. Okay, this is the example. However, we already get the solution for you. Okay, so basically the signal output look like the output voltage of a certain op amp appear as so in the following in response to a step input determine slew rate. Okay, the output goes from lower to upper limit in 1 second. That means from here going up to here. Okay, that means 90%. Okay, of the lower and 90% of the higher. Okay, the limit are taken at the 90% point as indicated. So upper limit is positive 9 volt, lower limit minus 90, minus 9 volt. The slew rate is equal to delta V out divided to delta T. That means 9 minus 9 divide 1 microsecond. That's why the answer will be 18 volt per microsecond. Okay, so that is the example in order to calculate the slew rate. Make sure you can understand. So later on, when you need to calculate the slew rate, you're able to know how to do it. Okay? Basically, that is the minus maximum voltage. This is the plus. Okay? However, you will be using the 90%. Okay? Remember that 90% of the positive and 90% of the negative. Okay? Now, relate problem. When a force is applied to an op amp, output voltage goes from -8 to 7 volt in 0.75 microsecond. What is the slew rate? Let's see. Output voltage goes from -8 volt. So basically, for this example, you get a -8 volt here to +7. Okay, and the time 0.75 yield second, microsecond. Okay, they want the slew rate. So, slew rate equal, okay, 7 minus 8. Okay, and that divide 0.75 yield. Okay, so see what you get. 15 divide 0.75. You get 20. Volt per microsecond. Okay, so if you get any question, let me know. Otherwise, keep going. Let's see here. Gain, bandwidth, product. An increase in closed loop gain caused decrease in the bandwidth. Unity gain bandwidth equal the gain ACL time to FC, cutoff frequency. Okay, now see example here. Determine the bandwidth of the amplifier. Okay, the amplifier show here. That will be an inverting amplifier. Okay, and the gain will be minus 747 divided 1K. Okay. Now let's see. Both of now. Determine the bandwidth of each op amplifier. So both op amp have an open loop gain 100 decibel and a unity gain bandwidth 3 megahertz. Solution. For the non-inverting, they're talking about that one. The closed loop gain is ACL 1 plus RF over RI. That means closed loop gain 67.7. And cut off. Okay. This is the formula. Unity gain divide to the gain. Okay. Unity gain here 3 megahertz divided by the gain to the gain 67.7. The answer will be 44.3 kilohertz. Okay. Now, a second one for inverted amplifier. That's what they're talking about. This circuitry here. Okay. ACL, that means op amp gain equal minus RF over RI, given you minus 47. So cut off frequency, okay, equal unity gain divide gain. Okay, unity gain bandwidth given, okay, 3 megahertz divide to the gain. You get answer will be 63.8 kilohertz. Okay, so basically that's very just a simple calculation. Only you recognize, okay, whatever they given to you. Now, remember, when you're looking the display look like this thing, that means that coming out from the left volt. Okay, try to understand. So when you're working on left volt with the operation amplified, you'll be happy a lot. Okay, this circuitry here, they call a differential amplifier. Why they call a differential amplifier? They're not inverting They not non-inverting. They not summing amplifier. They not unity gain amplifier. The reason they call a differential amplifier, the thing is V1 apply negative, is V2 apply positive. Okay? That means they get two input. So the differential amplifier, okay? So a two input circuit that amplify the difference between V1 and V2. V1 connect to the inverted, okay, of E1, and V2 connect to non-inverted. Okay, when R1, R2, R4, okay, you get R1, R2, R4, R5 are equal the value. The different amplify subtract V1 and V2. That means the Vout will be equal V2 minus V1. Okay. In the practice, the input impedance for V1 equal the ohmic value of R1. The input impedance for V2 equal the ohmic value of R2 plus R4. R2 plus R4. You know that the voltage divider right here. Okay, that they're talking about the impedance. A different amplifier circuit combine the gain effect from inverting and non-inverting resistor ratio. Okay, for V1. If you want to calculate the first thing, you have to remove that input here. Okay, calculate for V1 only. So V1 connect to a negative and that positive ground. So they will be an inverting amplifier. Okay, so Vout will be equal V1 times the gain of inverting R5 divide R1. And that will be minor. So basically, in this case, you want to do calculation. So that you have to remove that V2 here. Okay? So input positive will be connected to the ground. So that will be a inverted amplifier. You get this is the output. And now you want to calculate the V2. Okay? Then you route it V1. So they will be a non-inverting amplifier. Okay? So V out for non-inverting equal V2 times, okay, R4 divide R2 plus R4. You know what is it? Basically, this we can call a VA. That means they want the VA right here. Okay? The thing is, formula have to get the input at positive, not V2. Input have to be connected directly to the positive. So that's why voltage divider. Okay? So basically they will be V2. Okay? Time R4 R2 plus R4. Voltage divider. Okay? And anything will be tied with the 1 plus R5 divide R1. That means the gain. This will be the gain. Okay? You get that? Remember, when you want to calculate the voltage applied to the positive, make sure that have to connect directly to the positive. Okay, not V2. So that's why you have to be using voltage divider to calculate the voltage right here. Okay? Okay, see next one. What they say. If V1 and V2 equal 6 volt, VL equal A or B or C. Who knows?
Three volts.
Would it be 0?
Now, you have to tell me A, you select A or you select B or select C. Remember, they given you V1 and V2 6 volt. A or B or C.
C is in Charles.
You say C, right?
Right, C.
You get it.
Half of 6 is 3, and both of them are 10 Ks.
Perfect. The correct answer will be C. Okay? The thing about the input we want we chose 6 volt, one invert one not invert, output 0, correct? However, you have to looking for the VA right here. Okay? Looking for the VA. Then VA will be voltage divider. You get a 6 volt here. You times 1K divide 1K plus 1K, 2K. You get 3 volt. So that's why only the answer right will be C. You see that? That's a right answer. Correct, V1, V2 are equal. And again, resistor are equal. Vout is 0. VA equal 3 volt due to the resistor divider. Now, in this circuit, the sine wave generator applies an unwanted common mode input signal. V common mode to both circuit input. Okay. Due to the common mode rejection of U1, the sine wave does not appear Vout. We're already talking about common mode rejection ratio. Okay, that means input and output, they get exactly the same signal. So that's why they support that is the noise. That means the unwanted signal. And the op-amp try to protect. They don't want that signal appear in the output. Okay, the thing is, they consider to be the noise. Common mode input voltage. A cross inverting and non-inverting input of a different amplifier. Across both input of a different amplifier. A or B?
Is it B?
B, right? Correct. That will be a B. Now, in this different amplified circuit, resistor R1, R2, R4, and R5 are much equal to each other. Due to the resistor value, Vout equal V2 minus V1, or the difference between the input voltage. Okay, the output voltage polarity is determined by the relationship between non-inverting input voltage V2 and inverting input voltage V1. V2 polarity dominates the V1 polarity and determine the output voltage polarity. Okay? That means they're telling you they get your input V2, V1. Okay? So basically, the output will be the difference. Okay? Between two input. So which one is dominated? Output will be follow that. We'll see here. The following relationship apply U1. U1 is not saturated to the circuit, so that means V1 equal V2 minus V1. VA, that's the voltage at the positive, voltage divider. Okay, V2 times R4 divide R2 plus R4. VD means the different voltage, okay, between positive and negative equal 0. That's normal, okay? And the VA equal here. That's the VR4, okay? That they try to explain to you everything in this circuit. Now, in this circuit, S1 is used to switch V2 to V1. Okay, right now they connect to V2. If you want to connect V1, move it up. Okay. V1 into circuit. Okay. So V out here vary between 0 and plus 10 volt DC is essentially 0 for either at one position. Vary between 0 and minus 10 volt. Both A and C depending on position up at 1.
Mr. Pham, when you they different polarities depending on which switch is on V1 or V2. So
Right.
what is VO? How does that affect VO? How does it affect VO?
Now you just try to work with V2, right?
Right.
I think they connected V2. Okay. So V out. I don't understand on that one. How come they get 10 volt? You see that? That coming out from left volt.
Maybe it's a typographical error.
I don't know. But that's only telling you the output will be going either from 0 to 10 or 0 to minus 10. Okay? 10 or minus 10 maybe they will be a saturation voltage. Okay? So if we connect V2, okay, then V out will be equal. Let's see. Both inputs will be the same. Okay? Then output should be let's see 10K 10K that means minus 1 and 10K 10K here divide by 2 V2 divide by 2. Okay, so vary between 0 volt and 10 volt. So either you can using that or you can connect up to V1. Okay, so the answer will be, I think, okay, will be D. Both A and C They can be going 0 to 10, or they can be going 0 to minus 10, depending on, look like the saturation voltage. Okay. Okay, the answer will be B. Essentially, 0 volt for either at one position. Correct. If the input voltage to the different amplifier are equal, output voltage is 0. That means the V1 and V2 equal. Okay. Then the output voltage will be 0. That means now switch going to V2. That means V1 here and V2 here. Okay. At this point, the same voltage. So the output will be 0. If you move that one to V1 and input here the same voltage V1, they be 0. Okay. Either at one position. So that answer right will be B. Now, the different amplifier combine input waveform and account for amplifier and the phase. Okay. You see that is the input V1, input V2. They cannot be identical. Okay. If R1, R2, R4, R5 are equal, Vout will be equal V2 minus V1. So, based on the circuit information, Vout equal 2 volt, 0 volt, 4 volt, or minus 2. Which one? Okay, I think they're giving you answer here. 4 volt. Correct. V2, V1 are out of phase. Therefore, input voltage are added. Okay, that means 1 2 volt, another minus 2 volt. So minus to minus, that's what to get 4 volt. Okay, so basically, that will be done with the operational amplifier. Okay, only thing I want, you don't have to read in too many different textbooks. Only go through that handout. Read over and over. Okay, that will be helping you to understand. Okay, and next time, okay, next meeting, you will be download the JFET for DC. Okay, that means a second transistor. The first one we already done, bipolar transistor. Okay, and the bipolar you have to learn this. First thing you have to talking about the DC voltage. The second thing we're talking about amplifier. Like you get common base, common collector, common emitter. And now, when we start with the JFET, first thing we have to learn about DC first. That means we need a DC power to make the transistor working. Then, after that, we will be learn the amplifier. Okay? Same thing. They get a common source, common gate, okay, common drain. On the same thing, on the tree. So that's telling you we really go into the end of take one for the electronic. Okay? So up to this point, you get any question, anything? If not, okay, so I will be stop the Zoom today. Okay? So hopefully everyone get a good weekend and have a good holiday.
Thank you,
Thank you,
Professor.
you too.
Bye bye.